We got all these square roots. This is pretty similar to what we did yesterday. You might have forgotten or not understood what we did yesterday, but let's go over it again. How do I get rid of these square roots? Square. So the right side is not a problem, right? This is fine. But the left side is a bit of a problem. Because when we square the left side, we have to take all of it times all of it. So it's actually a FOIL problem. So the left side written out completely would look like this. And the right side is just going to be x minus 6 because the square cancels out the square root. Okay, the left side is a FOIL problem. You should think of the square root of x plus 3 as one term. And that's the second term, minus 1. So if I FOIL, what would the first times the first be? X plus 3. Okay, you guys remember this principle from yesterday? When you use square root times itself, it always just equals that whatever's in the square root. So, yeah.
Oh, wait,
so the square root of x plus 3 times the square root of x plus 3 is x plus 3. Okay, that's the first. The outside would be negative 1 times square root of x plus 3, which is just negative x plus 3, or negative 1 square root of x plus 3. The inside is the same thing. And the last is negative 1 times negative 1, which is plus 1. That was weird. It's like you tried to not belch and it escaped. What?
How many no solutions are in this section?
There's like one no solution in the A section, one no solution in the B section. But if you will recall yesterday I said 6 and 8, you should find two answers, but one of the answers on 6 and 8 should not work when you plug it back in. And there's a couple other problems that have no solutions on the evens as well.
So B section has one no solution on B.
Yes.
Okay.
Yeah.
So when we find the two thingies, do you want us to write down the second one even if it doesn't work?
Well, that'd be kind of part of showing your work, but you need to like exit out or circle the right one or something. Okay. What do you guys think now? Any ideas? How can we clean this mess up?
You add like
Okay, like terms. I'm guessing you mean these two things.
yeah.
Negative 1 square root of x plus 3 minus 1 square root of x plus 3 is just negative 2 square root of x plus 3. Anything else? Does somebody see anything else we can do? Plus 3 plus 1 makes plus 4. Anybody see something else we could do? Okay, remember, yes, if we have x on both sides, what did we do yesterday? We just subtracted them and they just went away, right? So, kind of just scratch those out. And then over here we just have negative 6. Okay, so it's actually getting a lot simpler. This is when it starts getting more clear. Do you guys know what to do next? Yeah, it's kind of like this problem, right? Like minus, divide. That's kind of what we're doing. We're getting the square root by itself.
Do they all factor?
Well, the ones that are quadratics do factor, yes. This one is not going to factor because it's not going to be an x. There's not going to be an x squared to factor. I don't think the b squared has any x squared. Or sorry, the b section does not have any x squared problems. So it's just the a section. All right, so the 4 is gone. Now what do you guys think we should do? Divide. both sides under the square root. You can get rid of it. Square, so it's just x plus 3 equals 25. So, yeah. But what should I remember to do? Plug it back in, make sure it works. 22 plus 3, these weren't here originally. 22 plus 3 is 25, square root of 25 is 5, minus 1 is 4. Forgot what was I plugging in? 22 minus 6 is 16, square root of 16 is 4, so yeah, it does work. Voila. Thirteen is almost identical to 11, and it kind of gets easier after that. Okay, do you guys remember what 2y plus 5, anything to the 1/2 power, what does that actually equal? Square root. So I'm just going to write it as the square root of 2y plus 5. And yeah, some of you noticed on the A section there's some 0.5 exponents. That's the same thing as the 1/2 power, so that's also a square root. I don't know if that was like number 8 or something like that. 6, 8 and 10. Yeah, 8 and 10. Those are just square roots. Those 0.5 powers. Okay, so we got plus 4 equals square root of 2y plus 9. Okay, so just like last time, we can at least eliminate the square root on the right side if we square both sides. The left side might take a little bit of doing, because there's two different terms over here we're going to have to FOIL. Square root cancels out. Okay, very similar to what we just did. So first, what's square root times the square root here? Right, 2y plus 5, the square root goes away. And then the outside is 4 times square root of 2y plus 5. Does not simplify. Inside is the exact same thing. And the last is 4 times 4. Okay, now we clean it up. What can we do to clean it up? Like terms. 4 square root of 2y plus 5 plus 4 square root of 2y plus 5 is 8 square root of 2y plus 5. 4 of those plus 4 of those equals 8 of those. What else can we do? Plus 5 plus 16 makes plus 21. What about this 2y though? Subtract 2y and they, what a coincidence, both go away. It is possible to solve if they don't go away, but that would make the problem much harder, if you can believe it. It does get harder, but not in this class. Alright, so we just have 69 over there. So it's getting more basic. Now what? Subtract 21. Cleaning it up, cleaning it up. Then Okay, so now we can get rid of that square root. So that's gone. So we have 2y plus 5 equals 36. Now we're getting very basic. 31 divided by 2. So the book just left it, you can say 15.5, the book just left it as 31 over 2. Okay, now technically, yeah, we should go back and make sure it works in the original problem. Pretend that I did that already, it does work. It makes both sides equal. Since these problems are hard, sometimes what I do is I give you like 1 point for showing the work and then 1 point for the right answer when we have giant problems like this. Kind of make up for the difficulty level. But I would still probably only count the odds as 1 point since I'm helping you guys. Number 15, 2 cubic.
Is it easier now?
Yeah. Does it look easier? I don't know if you can tell or not, but it is. This, like where 15 is starting, is like 2/3 of the way through the last problem. It's like close to solve. What do you guys think? What should we do first? Well, what's different? Let's point out what's different about this one. Yeah, the cube root. It's not going to change our work very much, though. Well, what do you think we should do first? Yeah, right. Kind of the same thing as the last thing. So, yeah, you want to get that cube root by itself, and then we'll handle it at that point. And then what do we do about the 2? Divide. And then, yeah. What's the opposite of a cubed root? Cubing it. Like, you know how we normally square it to get rid of the square root?
That's a really good group.
That one?
No, the other one.
Good 3? No. Okay, anyways. Thank you for your input. So over here, these will just go away. So we got y plus 5. What's 2 cubed? 8. Actually, when you cube both sides, I'm not sure you can get a wrong answer, now that I think about it. But this is like the only problem that has a cubed root, so it's not going to help you very much. But y equals 3 does work if we plug it in. Number 16 is actually more like number 17, so this 15 won't really help you very much with 16. 16, 17, 18, 19, 20, they're all kind of the same. But they're not hard, they're not bad. You just need to see the trick once, at least. Okay, 17. 3 times equals 54. Okay, what the heck is going on right there? What's that? Well, you don't have to, I'm not going to change this, by the way. I'm not going to rewrite this. But what it means is this is like x to the 3rd power and the square root of that. You guys remember that? Like this is the power, this is the root. Invisible 2 right there. That's what it means. So you could get rid of it by like squaring and cube root, taking the cube root of both sides. That's not what we're gonna. That's like the hard way to do it. The opposite of square root is squaring. The opposite of cubing is cube rooting. It's not really a word, but that's not what we're gonna do. Okay, let's go back to 7th grade here for a second. 3/4 times what equals 1? 4/3. Remember what happens when you multiply fractions? Like that. It's like 1/1. It's 1. So, and anything to the 1 power, if we can turn this into a 1, is just equal to itself. Okay? So this is kind of where we're heading here. Actually, let's clean this up a little bit. How can I get rid of that 2? Let's get rid of that 2. Divide by 2. $54 divided by 2 is 27. Okay, so what I will be doing is, to get rid of this 3/2 power, I'll be taking this, here, let me write it this way at first, then I'll fix it. I'm basically going to be taking this to the 2/3 power, because these would multiply together and cancel out. So here's how I'm actually going to write. I'm just going to put to the 2/3 times 2/3. And then this side would have to be taken to the 2/3 power. Okay, so you just flip it. And what happens is these kind of just, cancel out, and it's a 1. A plus 3 to the 1, it's just a plus 3. So that just fixes our mess up there. On the right side is 27 to the 2/3 power. You probably want to use your calculator with that. You guys know how to do, it's not 27 times 2/3, okay? We're not multiplying by a fraction. It's 27 to the 2/3. You guys get it? The 2/3 power, that means like the 3rd root of 27, and the 2nd power is like, but you can let your calculator do it. It should come out as 9, because the 3rd root of 27 is 3. 3 squared is 9, but let's see if you can get, I want to make sure, because the other class had a little bit of trouble, that we can all get this to come out on our calculator right, like we know what buttons to push. So if you get 9, that means you did it right. No calculator. I think I'm down to 2 white. Who grabbed one of my white calculators today? 1, 2. Yeah, I think I'm down to 2. I started this year at 4.
I used one yesterday, but I put it back in the thing one day.
Yeah, I've had 2 for like since Christmas, before Christmas break. Anyway, 27 to the 2/3 is 9. So as you can see, that pretty much fixes all our problems, doesn't it? So A is 6.
Oh, no, because of the
Are
black.
you expecting work on the
Dude, look at your reflector
Because
on
I'm
the
not
bottom
doing
right.
work on the
Your water just like.
I'm expecting I'll just give you half credit and then we don't have to worry about it.
What? Like, how hard I'm trying.
What are the odds?
And you only wind kind of a lot. All right. Number 19.
Are you serious? Like, you want to work?
You have to show your work.
Well, I question.
I'll let it go on the odds, yeah. But why might you want to show work on the odds? So you can look at it on the evens?
Well, you didn't post a video like you didn't do the other day.
We don't have to live with it.
Autism syndrome.
She uses math, whatever.
It's just like a thrill, like.
I mean, I told them what he done it.
Okay, so that's kind of what we do on all these last 5 problems. It's the same thing on this one. This one's actually a little easier because there's no 2 in front. So how do I get rid of that 2/3 thing?
Yeah, hard.
like 2 to 3 halves. So that's gonna go over here.
Isn't that right?
It's not too big.
Huh? Oh shoot, I did that I'm getting blind. I did that in the other class. Okay, that was actually to the 2/5.
I thought I was going crazy.
That was to the 2/5, not the 2/3. So we actually need to do 5/2. I'm an old man, people.
No, you're fine.
I'm gonna have to get glasses.
Don't be like my
David
dad.
got glasses.
Happens to the best of us.
He's like 8 or dog years.
Me and Hope, we're getting up there. We need those
He
glasses.
didn't exist.
Nah, you're
He's
almost
not
time.
Yeah, we don't.
I know, but
Dumb.
the old joke goes with you, Hope.
I
Okay.
don't even know.
Oh.
Okay, so I don't think that was necessary.
Also,
Necessary? No. Enjoyable? Yes. What? Okay.
What? What?
So the 5s go away.
Dude, autism is.
Blah blah blah. So, all right. This one kind of has a. I didn't really make the other class do it. I probably won't. I guess I won't make you. Here, I'll do it on the odds on 19, but I'm not gonna make you do it on 20 because 20 is about like this. So what's happening over here with this 2 on the bottom is we're taking the square root of 9 and then we're to the 5th power. And do you guys remember when you square root both sides, like that you had to do like plus or minus? So if you plug this in your calculator, it would be 243, but technically it's, because this is actually a square root, it's actually plus or minus 243.
Bro.
Okay, we've kind of dealt with enough. I'm not going to make you guys do that. But actually, yeah, this does have 2 answers. We do still have to subtract 3. But if you just get the positive answer on 20, I'll call it good. So the actual answer on 19, though, since I'm doing it, I'll go ahead and do the whole thing. 243 minus 3 is 240. And negative 243 minus 3 is negative 246. So it actually does have 2. The other class only had them do the first answer. They do both work.